Okay, we're at exercise 28. And exercise 28 is where we start to get into my more advanced Makefile. Now, the Makefile style I'm using is GNU Make. And GNU Make has a bunch of tricks. Now, there's even a better make that the BSD folks have. So there's BSD Make. And BSD Make is so good. Let me just show you something really quick. So here's the free BSD projects make, and it uses that same syntax. But there's this thing called package source. And the make that the BSD folks have is so good, they actually are able to create cross-compiling build systems that will build you packages across every single operating system you could ever imagine. It's pretty impressive. So for the cream of the crop of Makefile systems, it's definitely the package source or the NetBSD make, which is just the BSD make. Let me move this browser down here. So, but you're using GNU Make, which is nothing to laugh at. GNU Make has a lot of very similar, very great features. I'm going to show you how to use the skeleton, and you can use the book to sort of like figure out what files go where and how to build the skeleton. And remember, you can also check out the code, and I'm going to show you two places where you have the code. So there's the lib learn see the hard way GitHub that you can actually check out to see a real example of using the skeleton and the Makefile to build something. And then also the C skeleton is in the lectures. So I'm going to use the skeleton in this video, which is a little easier to see in a video. Okay, so first things first, let me just sort of show you where you can go. So github.com zshaw libLC the hard way. Okay, throughout the rest of this book, we will be building this project. So this is all of the project, or all of the algorithms, every exercise from here on out pretty much. And the only thing that's not in here is the very tail end exercises, 48 to 52, where we build a little server. And that'll be in another project directory somewhere. So if you get stuck as you're traveling through my book, you can actually grab this code and you can cheat. So it's totally fine to cheat if you need to. And also, there might be bugs or things that I fix up. So just come here if something's not working quite right. Always remember, make sure your stuff is compared to mine, and then you might actually find out that you're wrong and I'm not. Okay, so we have that. We also have the Learn See the Hard Way lectures, which is another repository. And inside that repository, there will be the code that I'm going to work with, the C skeleton code. So that's this code right here. So again, if you just do, I'm in lectures ex28 directory, and inside there is the C skeleton. So there you go. That's all you need to do to figure out how this, or how your code from the book compares to my code when making the C skeleton. Keep that in mind because it is a little difficult to build that. Okay, so the first thing I'm going to do is I'm going to quickly show you the Makefile for lib learn see the hard way, so you can kind of see a real project using it. Okay, so you see I have my option flags, and it's pretty much very similar, but notice I change the name of the target. And you want to look up this pat sub. That's a very useful thing in wildcard. These are variables that you're setting in the Makefile, but then these modify the results of the searches. So you can say, you know, wildcard, get all the .c files, and then pat sub. So I get program source is that. I use programs, pat sub, all the program source files to do this. There's also one other modifier that I have yet to commit, but I made this mistake and I didn't realize it till I got to the end of the book. So if you set a variable, so all of the tests get picked up, and then if you set a target here as, you know, like a variable that's a target, it generates all the tools or all the targets from one variable. So up here, just the same way I did this source, we're pulling up all the source, we're finding all the tests, and then if I do that, that says every single test in this test variable has the target of, and you can just do target, and I would also do so target. And that solves the problem where the tests don't get rebuilt all the time. So once we have that, and let me just make sure I am doing this for the very first time. There we go. Yes, it's only in one spot. Okay, so once that's an example, and this whole file it's pretty much stock straight out of the book, but then I add a few things here and that are necessary for lib learn C the hard way. Using the C skeleton, it's pretty simple. And I do this also later on when I make the final project. So first thing you do is I like to go into the C skeleton and clean it up. Make clean. Okay. Now I copy it. And I'm going to change it to EX28 really quick. EX28. Okay. So I made my EX28. Now, if we do ls source, I have a little lib EX29 in there. That's for the next exercise. And all I would do then is I just make let me make sure I'm in the right directory. I am not. EX28. Now, I would edit the README, the Makefile, and the tests, and the source. Okay, so the README, I would say this is a project, bleh. Just like that, nothing big. And then the next one, the Makefile, I come in and I find my target, and I'm going to change this to, let's call this EX28 really quick. And that'll pick up all the files. And then if I was going to start working on this, I would probably gut this file or just delete it and take it out and make new files. And then I would also then go to the next one and the next one, and I would gut this test. And that's pretty much it. I mean, literally, I would just come in here and I would just gut it. I would say this test is from the next exercise. So I'm showing you a little bit of what's going on in the next exercise, but I would come down. Let me get some more. Yeah, I would gut this, nuke that, gut this, rename that dummy, come down here, and rename that dummy. Okay, so once I do that, I just rebuild, and there we go. And that's not being used. Oh, and then so I can come in here to this file and gut this one too. I would just do that. Just nuke it. And then let's see, let's do make clean. Let's see what we got. Oh, yep, and then I got to come up here, return null. And there you go. And I started my little project. So that's really simple, and that's how you use the C skeleton. You basically just make a copy of it, move it over to your new directory, go in and start editing all the files. Now, so in the build, that's where your .so and your .a goes, and we'll get into linking later. Bin, if you put any .c files in there, they get compiled into a binary. So my pattern is I have a very short, small C file in bin, and it links against the libraries. And then most of the code goes in the libraries. The source files in here get loaded into that library. So you just make one library, dump your C code in there, and then you have your tests, and that's where you put your C tests. And that's it. So now, let me see. Let's take a look at the Makefile super quick from liblc the hard way so we can get an idea of what's going on. Now, I explained this in the book, but I'm going to really just break it down. Okay, Makefiles are all about a target, dependencies it depends on, and then a command or a sequence of commands, a script that goes under it. GNU Make lets you do really magic variables. So I can say, instead of saying sources is, and then I list out the sources one by one, I can say sources is run a wildcard on all the things recursively that are *.c. And for weird reasons, you have to say this twice, basically. And then I can say all the header files, find me all the header files. And then all the objects, so I have all the .c files in sources, and I can basically do a transform. Take anything .c and make it .o. So doing that eliminates a ton of editing. I pretty much don't edit this file unless I'm changing targets or I'm adding new, like when you add a new bin output, you sort of have to like make a new target sometimes to get the dependencies right. Other than that, there's not much else. You can then set up, the other thing you can do that's kind of funky is you can set, like I showed you previously, I can have a variable that has a bunch of targets in it, and then say each of those gets these targets. I can also repeat a target here, and then change variables that get set. So when this target is ran, I do -fpick. I'm adding to the C flags only while this is running. And then I run my AR and my commands. So I'm basically saying, hey, when you do the target, whatever that target is, add this to C flags. Okay, now this target depends on these. So build and object files. So I have to make sure build runs. And then AR and ranlib on the result. And the $@ symbol means target, whatever the current target is. It's a placeholder for whatever this is. So then SO target, I don't really need to set this fpick option, and some systems will still make you do that. So if that happens, you just move this down here and make a copy of it. And then I say, hey, it depends on target and objects, and here's your options. Now later on in the final video, I add some more options. So tests has an interesting thing. I want the tests to sort of run all the time. So what I do for tests is I basically just have a .phony right there. And I came up here ahead of time and I said tests depends on these things. So I don't have to really have any dependencies. Just the tests target is sort of a fake target. So I don't have to say each test as a target. Instead, I can just say run tests. And then I say it doesn't really depend on anything. Just run it. That's what the phony sort of means. And then I can do this. So it's not looking for any dependencies necessarily. It's just going to run it. If you're running Valgrind, here's a handy little Valgrind version of it. It reruns the things that you're doing in Make with your make command. And then cleans everything up. Now install is, you probably want to modify this. This is an example for lib learn C the hard way, but it's going to put it in include and LC the hard way. You wouldn't want to reuse this directly. You would want to change it for where you want your libraries to go and so on and so forth. This is, as I discussed in the book, this is a handy way to find all the bad functions. So it just runs a program called egrep to do a big regex search on your source and spit out any functions that are suspect. This seems to be the pattern that works. And I got this from a web server called and-httpd. Let me show you that super quick. I would like to give credit to him. And-httpd. This is a highly secure web server that I really actually admire. It's written in a very solid style of C. I'm actually a big fan of this. He gives out a $2,000 security guarantee. I actually don't know if it's a male or a woman. I assume it's a man. I'm not sure, actually. But from this, I got that regex. I believe it's listed on the page somewhere. And it's very handy, regular expression. And that concludes the end of this exercise. So read through the book, do the extra credit, and I will see you at the next one.